Okay, so as in the last video we have discussed about the wave and its classification. So today we are going to see what these waves are actually. Alright, so as I told you previously as well, that there are two types of wave. So the first one was mechanical wave. So let me write here, that was mechanical wave. There I just wrote they require medium to propagate. So here I am writing that point again because that's the most important point. Alright, require medium to propagate. So this is the most important point. Medium to propagate or to travel. Propagate. Alright. Secondly, mechanical waves cannot travel in vacuum because we know that in vacuum there is not any medium. So as I told you, they always require medium to travel. So in the vacuum there is no medium. So in vacuum mechanical waves cannot travel. So let me write that point as well. What I told. Alright. I told mechanical waves cannot or can't travel in vacuum. Travel in vacuum. Alright. So the third point is what? I am going to tell you the example, like what are the examples of this mechanical wave. Let me change the color first. Alright. So sound waves, waves on the surface of the water and waves in a string are the example of what? These are all mechanical waves. So let me write here. Sound waves, waves on the surface of the water, on surface of water and in a string. etc. Okay, if I do talk about any one example of these, so I'm just going to take this sound wave. Alright, sound wave. So how sound wave will not travel without medium? Wait, sound wave always require medium to travel as it is a type of mechanical wave. So mechanical waves require medium to travel, so sound wave will always require medium to travel. Alright, and this was proved by an experiment which was known as bell jar experiment. Let me write here as well. Bell jar experiment. Alright, what was done in this bell jar experiment? Like there was one jar, alright, and here inside that jar they have put one bell. Alright, so basically this is the bell. I don't know how to make that, but understand that this is the bell, and this was connected with two wires outside. Alright, here was the battery of this. So let me make here the battery. It was connected to, alright, here it was connected to a battery, and downside there was a pump, alright, vacuum pump. Here it was vacuum pump. Alright, so when we connected these two wires to this battery, this bell started ringing. Alright, and here there was inside the medium, there was medium inside, and that was air. Alright, so air was the medium, and we were able to hear the sound of this bell. Okay, so we took out this air from this bell, not bell, from this jar. We initially what we did, we switched on this vacuum. And what this vacuum did, vacuum sucked out whole the air which was filled inside this jar. So this whole air was sucked by this vacuum, and now there wasn't any air inside. All right, now there wasn't any medium inside this jar, so this sound was not able to be heard. So this sound was not able to be heard. So this experiment proved that sound always requires medium to travel. If there would not be medium, then there would not be any mechanical wave. All right, so as we have proved this as well. So now, as I told you, mechanical waves are subdivided into two types. All right, those are transverse waves and longitudinal waves. So let's see what these waves are basically. So first one is what? Transverse wave. Wait, let me write here down. Wait, mechanical wave has two types. So the transverse wave, and the second one is what? It is longitudinal wave. Longitudinal waves. Alright, so what are transverse waves? Transverse waves are waves in which vibrations of particles of medium is perpendicular to the direction of propagation. Alright, let me write here down. These are the waves whose vibration of the particle particles of medium. All right, vibration of the particles of the medium is perpendicular to the direction of propagation. All right, so this was the point as I wrote in my last lecture as well. So what are the examples of these? Let me write this here. So the first example is light wave. Light waves are also known as transverse waves because they travel in the form of crust and trough. All right, and waves on the surface of water. Waves on surface of water. Surface of water are also known as transverse waves. All right, as I can make here the diagram of this as well. So basically this is the wave, and they'll always travel in the form of crust and trough. All right, this would be crust. We'll be talking these properties as well, and this is the trough. All right, so they'd be moving like that. So now what are longitudinal waves? So longitudinal waves are waves in which vibration of particle is parallel to the direction of propagation. All right, so let me write here vibration of particles of medium is, this is for parallel. All right, parallel to the direction of propagation, to the direction of propagation. All right, and what is the example here? The best example is sound waves, as we have seen. All right, sound waves. And how these longitudinal waves look like? Wait, let me make the diagram of this as well. So here would be compression and then rarefaction, then compression, then rarefaction, then compression, then rarefaction. So they'll be moving like this. So basically this part is known as compression, and this part is known as rarefaction. All right, compression and rarefaction would be there in the longitudinal wave. So as we have discussed about the mechanical waves, now what are the electromagnetic waves? No, we are not going to discuss electronic wave now, but we have two more types of this mechanical waves are there too. All right, and those were what? Those were progressive waves, and what? Those were standing waves or stationary wave. All right. So those were based on what? On the basis of energy transfer. There were two more types. So the first one is stationary waves, and the second one is progressive waves. So I am going to write here the standing waves, or these are also known as stationary waves. Alright, so what these waves are basically? Waves which do not transfer energy. So these are waves which do not transfer energy. They won't transfer energy. Alright, transfer energy. And what's the second type? That is a progressive wave. Wait, let me write that as well. Progressive waves. And what these are? Waves in which energy would be transferred. Waves which transfer energy. Alright, so these are the two types which are based on the energy transfer. Alright, so now we have the last wave, which is the electromagnetic wave. So we'll be discussing about that as well. Electromagnetic waves. Alright, so they do not require medium to travel, as we wrote in our last class as well. They do not require medium to propagate. Alright, those waves are known as electromagnetic waves. So the best example of these are what? These are radio waves, because these electromagnetic waves can pass through can travel in the vacuum as well. In the vacuum, as we know that medium is not here, so they'll travel without medium as well. UV waves, which are ultraviolet waves. Then we have X-rays. Then we have gamma rays. Gamma rays and etc. So this was the classification as we did in the yesterday's class as well. So this was little bit more about those waves. Alright, so this was all for today.